Hey space friend, I have some exciting news. I think there is an alien out there trying to communicate with me. I received a transmission in Morse code and I'm using an OLED display to interpret it. So let's see what it says. Alright, I'm ready. Booting up. Okay. Do what? Better. Let's figure out how they would have put this message together using Arduino, and then we'll do a second project to send a message back. Nope, my feelings aren't hurt at all. I'm not salty. For the first project, we need an LED, a 220 ohm resistor, an OLED display, and 8 jumper wires, 6 of them male to female. First, we're including our 3 libraries, and then we set our pins. To install these libraries, go to Tools, Manage Libraries, and search for the name of each library. It may give you the opportunity to install dependent libraries when you do one, so go ahead and install anything else required. I have another video dedicated to OLED displays, so I will link to that at the end of this video if you want to watch it to get more information about what exactly it's doing and how it works and what this initial code is doing. Const int dot duration equals 200 is a single dot in Morse code that will turn the LED on for 200 milliseconds. A dash is 3 times longer than the dot, so we multiply the dot duration by 3 to get the duration of the dash. The space between parts of the same letter, like a dot and a dash, is 1 dot duration, so we set symbol space to that. The space between letters is 3 dot durations, and the space between words is 7 dot duration. String words is an array of the text versions of what we're printing onto the OLED screen. String Morse words is a 2D array that holds the Morse code representation of each word. The 6 in bracket sets the number of columns, meaning the max letters in a word in this case. It's sized to fit the longest word and tells the compiler that each row can hold up to 6 elements. The compiler needs to know the size of the second dimension when compiling so that it knows how much memory to allocate for each row. Word length tells the program how many more segments to read for each word. Do has 2 letters, so use the first 2 elements of row 0, and better has 6 letters, so use the first 6 elements of row 1. In the setup, we set the LED as an output and turn it off to start. We then initialize the OLED display, fill the screen black to clear it, set the font size, color, and placement, then print booting, and then we clear the screen again. This for loop initializes W at 0, and while W is less than 2, increase W incrementally by 1. Here we're using W to mean words, and stating while it's less than 2, since we have 2 words to loop through, starting at 0 and then 1. We fill the screen with black, set the cursor, and then print each word using the loop. The next for loop starts a loop that goes through each letter in the current word. W is the current word index, where 0 is do and 1 is better. Word lengths with the W in brackets is telling us how many letters or Morse code segments are in that word. I is the index of each letter or Morse segment in the word. We then call the blink Morse function to flash the Morse code. Morse words with W and I in brackets gets the Morse code for the I-th letter of the W-th word. So for example, Morse words 1-3 is the Morse for the 4th letter of better. Then we delay by the time that we set in letter space earlier. After the inner loop finishes, indicating that a full word is done, we delay by the word space we set. After both words are finished, we delay a little longer. The blink Morse function takes a Morse code string and blinks it to the LED. We're using code, which will be of type string, as an input parameter. This function is going to loop through that string, read each character, and then blink it as a dot or a dash. The for loop runs once for each character in the Morse string. I is the index of the current character being processed. If the symbol is a dot, then we're going to turn on the LED by writing high to it for the amount that we set as the dot duration. If the symbol is a dash, then we're going to turn it on for a little bit longer using the dash duration. Then we turn the LED off and delay it by the symbol space. For this second project where we respond to the aliens, we're going to add a buzzer. Keep most of the setup the same, but connect the S pin of the buzzer to pin 6 and the VCC lines of the buzzer and OLED display to the VCC sign on the power rail. Then connect a jumper wire from the positive sign of the power rail to 5 volts on the Arduino. Also connect the ground pin of the buzzer to ground on the Arduino. We leave the first section the same except for assigning the buzzer to pin 6. The string alphabet variable holds all of the valid input characters that we want to support. It's our reference for converting typed characters to Morse. The string Morse code array creates Morse string codes tied to all those letters and numbers. The empty string input message stores whatever we type into the serial monitor. In the setup, we set LED pin and buzzer pin as outputs and start them as turned off, and we start the serial monitor. Then we initialize the OLED display, same as before. Serial.println prompts us to type a message. Then within the loop, we're checking to see if anything was typed into the serial monitor. We read the message up to the new line, trim any white space if there is any, and then convert everything to uppercase to match the dictionary that we created. We print out the word sending and then the message we entered onto a new line. Then the display is activated to print all this out. Send Morse calls the function to convert and send Morse signals. And then the display shows done after the message is sent. It holds for 2 seconds and clears the screen. The send Morse function loops through every character in the user's message. If the character is a space, then we pause for a word break and skip to the next character. String Morse equals get Morse loops up the Morse code for the character string get Morse. If it's found, it displays the letter on the screen, blinks and buzzes its Morse equivalent, and then delays between the letters. The blink and buzz function loops through the characters in the Morse code, uses the signal function to flash and buzz for the appropriate duration, and then adds a pause between symbols. The signal function turns on the LED and buzzer, waits for the duration, and then turns both off. The display letter function clears the OLED display and then displays the letter being sent. Get Morse looks up the Morse code that matches the character entered as the parameter. It returns the corresponding string from the Morse code array. And if there's no match, it just returns an empty string. I'm going to respond to their petty do better message with a simple WTF. I always forget how much I hate buzzers until I listen to one again. Ooh, I'm already getting one back. Hope you enjoyed your cryo sleep, sucka. Did the aliens lock me in the cryo chamber? So either they've been on my ship or have some sort of control over it. I think the next time I might get the distress beacon rigged up in case this continues to escalate.